to be able to 3D print parts with grayscale gradients. But how do you do that? So we make a part using something called vat photopolymerization, which we do inside of a 3D printer like this. Inside of this 3D printer, we have a vat, which is full of our resin, a build plate, which lowers itself down into the resin, and underneath here, we have a projector. The projector projects an image onto the build platform, and then the resin inside of the platform cures when exposed to the ultraviolet light. However, if we're trying to apply a grayscale gradient, how do we make sure that this kind of projector actually is projecting a gradient? To prove that grayscale gradients do work and can be printed, we use this experimental printer setup. On it, we have a projector. We then have our build vat right there, and then we have our build plate. So what we can do is we can use this custom MATLAB program that can then take these images that we produce inside of MATLAB, send them to our 3D printer, and then we can print them. And we have been able to prove that our parts do in fact have a grayscale gradient, and we can print blanks of them as well, so that we can hopefully test them. But what if we want to have parts that we can also test inside of compression, not just tension? That question is a lot harder than initially thought, because most software that is used to develop 3D printing files can't apply a grayscale gradient to your parts. So what we do is we are using something that is called OpenVCAD. It is developed by PhD student Charles Wade inside of the University of Boulder, Colorado. And using Python code, we can now generate parts like this one that have a grayscale gradient applied to them. And because of the complex geometries that OpenVCAD allows for, we can make really cool parts to test inside of compression, like this ladder right here. But how do you make sure that it's repeatable? I'll show you. So what we do is we use this over here. We are using this laser profilometer. This laser profilometer allows us to get the height and width data of different samples, and then if we compare their heights at different exposure times, we can figure out a working curve for our resin. Now, this working curve data is based off of this 3D printer. The reason why we are using this Asiga Pico 3D printer instead of the experimental 3D printer that is over there is because this 3D printer, for one, can print overnight, and two, it is much more reliable in terms of, printing parameters. So what we have to do though is we have to use a direct file uploader. We can't use the Asiga Composer, but we can, however, decide what kinds of files to upload directly using build any files, which are editing files for our print times and exposures and burn-in. Then we directly upload it to the printer, and since this printer is not exposed to the air like that one is, we can now finally print things overnight, meaning we can make really big compression parts for testing. But Chauncey, how do we actually test our parts? We go use a load frame and digital image correlation equipment, which we can find here. We go here, where we have a load frame and some DIC equipment so that we can take some tests. Now, our parts have a problem. They are extremely elastic, so when they are being pulled apart at the tensile bars, sometimes we can't really tell what the stress and strain is on the parts, which is the reason why we use these, which are two digital image correlation cameras. Now, what is digital image correlation? Well, what you do is you take a part, and for instance, you speckle your part with white and black. And when your part is going to be stretched, like this one is, these cameras will detect how far apart these have gone away from each other. So now we have one other issue that we're trying to figure out is how to retain this grayscale gradient. Normally when you're printing this resin, you need to have some kind of post-cure method. So that could be soaking it in ethanol, putting it inside of a heat-cured oven, or possibly doing both. Putting it in a heat cure and then soaking it in ethanol. If we can prove that the grayscale gradient is retained utilizing the load frames data as well as the DIC, then we can prove that this method of grayscale gradient 3D printing will have these parts be shipped out for something like a leg brace, and its material properties will be retained. But you can also think about how different energy dissipation works utilizing the compression tests. Since we have data from the hexagons and from the ladders and their buckling direction, you can try to accurately predict how the resin and its materials will hopefully apply inside of different kinds of energy dispersion scenarios, such as possibly inside of a helmet. Utilizing our working curve data, you can also try to utilize the different weird and wacky gradients that OpenVCAD allows for. And since you can line up the intensity of the lamp with how much cure depth our resin has, you can accurately predict what our resin will act like inside of different scenarios. So you can build more complex structures with even more complex material properties depending on whatever you need.